I welcome you all for the second session of today's uh, second session. Um, I am very much privileged to introduce Mr. Albert Einstein George, widely recognized as Albert Einstein G, is the founder and CEO of INL Technologies. With over 23 years of experience, he has established himself as a visionary in business strategy, advanced vehicle design, and multidisciplinary engineering solutions. His expertise spans strategic partnerships, computer-aided engineering, battery electric vehicle optimization, and key areas like crash safety, noise, vibration, harshness, and aerodynamics. Mr. Albert Einstein's professional journey includes significant contributions to leading organizations such as Larsen and Toubro Limited, Chrysler Technical Center, Magna Powertrain, and General Motors Technical Center. He has successfully managed over 50 full vehicle CAE projects, driven innovative strategies for crash-worthy car body designs, and executed more than 100 multidisciplinary design optimization programs for a variety of vehicle types. His leadership has been pivotal in advancing CAE capabilities, including online simulations and cloud-based computing for vehicle optimization. I welcome you, sir, for this session, for this uh, second session on AI-driven MBD for electrical vehicles.
Thank you very much, and very good evening to one and all. And really, it's a great privilege for me to join in this faculty development program through this webinar. And thank you so much for waiting till 8 p.m. and joining in this session. And I would like to thank the Registrar of Crescent University and the Vice Chancellor and HOD of the Dean and HOD of the department, Dr. PDJ Jayakumar, and also all the coordinating faculty members for this wonderful arrangements and coordinating such a wonderful faculty development program. Let's start into our topic today, what we are going to, discuss and learn few things. And as a faculty members, how we can update ourselves for the better research and also for a better curriculum development moving forward, how we can take it, these latest trends into our students, and further how we can guide them in innovative projects. So that is the main core focus of my presentations to all of the faculty members who have joined. I know many, more than 100 faculties and professors have joined. And when I compare their research experience and the academic intensive research activities, my experience may not be that much worthful, but I hope I would be able to share my presentation and my ideas and concepts to the faculty members for their understandings. Okay, and so the topic of which we have taken today is in the AI-driven MBD. Okay, so the terminologies may be a little tricky to understand and other things, but when we develop electric vehicles, okay, and how are we going to use the MBD methods and also the technologies like artificial intelligence for a rapid and accelerated development of the vehicles. So that's why I just wanted to bring some insights and how industries are practicing these areas that I wanted to share with you in this evening. And to give a brief introduction about the company that I work, and I'm currently heading the companies called INL Technologies. It's a purely a research and development company, and we are located in Chennai. And so we develop a lot of engineering solutions and AI softwares, powered engineering softwares mainly in the automotive manufacturing and construction. So basically, we are AI product development company. So that's a brief understanding about the company that that I come from. Okay, a small understanding. Okay, how the EV growth is throughout the globe. Before we get into deep into MBD and AI. Okay, so we all know as a faculty members, the world is moving towards the global vision, which is called decarbonization. We all know that the world is moving towards green energy. The great vision is accepted by the worldly leaders and the industrial markets to minimize the carbon footprint in the atmosphere to serve the humanity in this world. So it has been very nicely confirmed that whichever the industries or the vehicles which are emitting the carbons into the atmosphere, we wanted to completely eliminate that so that we can preserve the environment. So with that global vision, the EV growth has taken up because we are not going to emit any carbon out of that. So that is why the EV manufacturing and researches have been accelerated in the recent years, and all the manufacturing companies are jumping into the EV manufacturing, and there is a heavy competition is prevailing in this market that we have to keep it in our mind. And when we talk about the EV growth, and also equally, it is very important to understand how rapidly we are constructing the hydrogen-based vehicles also. Because in our topic, when I gone through the things, it is mentioned EV as well as the hydrogen. So we all know that the small vehicles and passengers cars can be easily charged quickly, and we can move off. But when it comes to big commercial trucks, which are in the other countries like United States and Canada, they drive continuously for 3,000, 4,000 kilometers, for the transportation of goods and other things. So when it comes to heavy trucks and long-term travels, it has been understood that continuous charging may not be possible. So when it comes to commercial vehicles, hydrogen-based or hydrogen-based fuel cell vehicles or commercial vehicles are more important for long-term things. So when we talk about hydrogen as well as the pure EV, most of them are very important for the green energy transition. So the concept goes like this. Small passenger cars can be easily charged. So the passengers cars are directly getting into EV. By storing energy into lithium-ion batteries, we would like to drive the cars. Whereas when it comes to heavy trucks and the commercial vehicles, still people prefer hydrogen-based vehicles. So this is the major difference between why we have EV in the passenger cars, why we have a hydrogen-based vehicle, mainly when it comes to the commercial segment. But thanks to India, recently I also got an opportunity to travel from Bangalore to Chennai with one of the Neo Go bus or something. I remember it's a purely electrical vehicle. They nicely, driving 6 hours journey with a purely electrical driven, vehicle. So there are for a short-term things, and with the arranged recharging facility, we are able to purely run the commercial vehicles also in a pure EV manner. So that is, we have to keep it in our mind before we get into topics. Now we are talking about model-based design. Okay, why model-based design? Okay, and people are thinking about it. And 5 years, 10 years ago, when the vehicle development cycle, when we look at every commercial vehicle or passenger cars, it takes usually it takes 5 to 5.5 years to develop the vehicles. But nowadays, every vehicles are developed and manufactured within 2 years time frame. So the time development cycle has been drastically reduced because of the competition and because of the technology availability and the various factors influencing the design cycle time. So when it comes to a design cycle time, in the EV, they wanted to quickly manufacture. The one great advantage when it comes to EV is from 60,000, say for example, when we go for a gasoline-based vehicles, okay, we used to have a very good IC engines, and where we have an 60,000 rotating components, say for example. Okay, it's a lot of mechanism, kinematics, arrangements, controls, mechanical systems. So the wear and tear involved in the IC engines are more. So assembling process is very huge. But whereas in the coming to an EV vehicle, from 60,000 to we are able to reduce the rotating parts or kinematics into 6,000 parts. Where is the 60,000? Where is 6,000? There is a drastic reduction. So the system is very, very much simplified. There is a motor, there is an inverter, and the control system, battery and battery management systems, and body structures. Okay, that forms a quick vehicle and carbon-free vehicle. So it is very well fascinated by the things. So it is very important to develop the system in a very quick manner. So every industry has a different requirements and different features they wanted to do it. They wanted to do a prototype building. Usually prototype building on those days happens in the CAD systems. Now also for everything, it is a CAD systems, but most of the system engineering part of the vehicle development, EV development, that is where we get into a model-based system design. So there is a lot of analytical models, as we understand. That is all numerical models. Any structural validations, when we do for a load, stiffness, torsional or bending, anything, that we will go for a computer-aided engineering. That means a finite element-based analysis validations. Any flow or aerodynamics or thermal simulations, we would be able to do computational fluid dynamics validations and design. But when it comes to a system engineering, when we talk about batteries, how the batteries are getting charged, there are a lot of electrochemistries that we need to solve, and how the torque is demanded by the vehicles. When the torque is demanded, how the energy is released from the lithium-ion battery while charging and discharging, what happens, and how do I control the system of an EV systems, like a battery, motor, and the inverter. How do I manage, and how do I connect, control the things related to accelerations and decelerations, braking, and regeneration of the energy during braking. There are so many number of system engineering factors influencing when it comes to EV. Whereas in IC engines, there is a system engineering, but more given on structural and the kinematics oriented simulations. But when it comes to an EV, it is more relevant to system engineering. When system engineering comes, we may not be able to depend mainly most of the time on the numerical things, rather than we will be waiting or we will be using analytical based calculations using tools like MATLAB. So when we form in a system, integrated systems in a virtual environment, where you have a motor models, that means a Simulink model, the induction motors can be completely, By inputting the parameters, you can get the realistic performance of that particular induction motors mathematically. In the same way, when you use a battery modeling in a Simulink MATLAB, you would be able to, based on the type of the battery and based on the number of cells inside the battery and the arrangements, cooling arrangements that has been made inside, we would be able to develop a mathematical model in the model-based system design environment, which can replicate or behave like a physical battery. So the great advantage of the model-based system engineering is you would be able to develop a mathematical model of every systems in a very nice way, in a very quick way, which can replicate or behave like in a real systems. So you have an arrangement of motor in a mathematical model. You have an arrangement of a battery. Whenever you change the parameters, the mathematical models are going to change the things. So when you develop all these things, you would be able to build a virtual prototype and system level integrations. And also you would be able to do a virtual battery management. And also you would be able to optimize the energies in certain simulation environment. Okay. And you would be able to develop further your control algorithm and trial. And also you would be able to, in the design phase itself, mathematically you would be able to detect the problems. Okay. And you would also verify your standard safety standards. So when this all happens in an analytically modeled system engineering environment, so that could be in a MATLAB-based Simulink models. When we use that, okay, you would be able to arrive an entire EV vehicle in a virtual environment. So it is very important. Sometimes, faculty members would have joined from power electronics and mechanical engineering, automobile engineering. Now the engineering has entered into a different world where even automobile engineers should know the system-based engineering model development using MATLABs. So the point here emphasizing here is it doesn't matter you are coming from the mechanical or automobile. Nowadays, a model-based design skills are very important. We all have to learn how to use the mathematical models and develop a Simulink systems to form the model-based design. I hope that you got an overall understanding of why the model-based design is coming into picture when we talk about EVs. Okay, now we understand a little bit why MBD is more significant in EV compared to a gasoline engine-based vehicles. Now, another important technology is coming into a picture, which is artificial intelligence. Many times, universities have formed artificial intelligence department separately. It is good, but my perspective is every department, AI should be a mandatory portion of their syllabus. Domain is very important. Okay, artificial intelligence is a technology or a solution that can be implemented across the domains. So it is very, very important to understand and implement AI into various domains. So I need not explain what is AI and what is the things. Because every faculty is, nowadays the students are very studious in developing certain algorithms and developing autonomous AI systems. But to highlight in the perspective of EV, we have to understand why this AI is coming up. Say, for example, okay, one of the area that I would like to share, when we talk about the AI and its implications or application in EV, let's take the battery, performance. You have a lithium ion cell battery. So you have maybe a 10 cell battery or whatever it may be. Okay, a safe vehicle. But when the vehicles are, driven in a different scenarios, the vehicles would have gone into hill areas, and some vehicle would have gone into a flat surface roads. Okay, and something would have gone into a different types of roads. And also when the different drivers with the different driving styles, when they use it, the battery energy utilization usually differ vehicle to vehicle. Then how do you calculate and estimate the the life of the battery, or the status of the battery, or the charging condition of the battery in a various scenarios? It's a very complex scenarios. Okay, we also would have known by using the cell phones. When we purchase a cell phone, sometimes we will get a 1-day charging. But as days goes, and when we start utilizing the cell phone in a different things, the battery life differs. So vehicle to vehicle, based on the utilization, based on the environment they drive, based on the temperature outside and other the driving patterns, the battery life changes. When such a complex systems is prevailing, okay, how do we understand and project the battery life and estimate the battery life to the user? So there, the EVs are using a lot of AI systems to predict and validate and project a very good right estimation of the EV charging status or battery status to the customer. Because when the driver drives, he has to plan the next charging port. So in such a complex environment, the softwares are, the algorithms are built inside the hardware. So when we talk about things, okay, there are a lot of machine learning algorithms are developed. When the machine algorithms are developed and embedded into hardware systems, and also it learns from the data, or it learns from the every signal that is generated from the vehicle, and it adapts when it adapts to the targeted numbers or re-estimate the projected numbers, then that system is said to be an AI system inside the vehicle. So in many areas, artificial intelligence are implemented in EV vehicles. So one of the area is, as I said, the areas where AI is mainly used. So mainly to you on the battery optimization, because we have to optimize the energy, we have to maximize the energy. That is one, and also we have to in the design and prototyping. And many EV vehicles are autonomous. Now today you go to California, San Francisco airport, and people are very common now. They call the autonomous vehicle in the app. It comes and they get into that. It drives safely. It drives back to that. So EVs are very well planned. Okay, and within the available energy and how long the person is, want to go, and it does all its intelligent decisions. Now EV vehicles comes with a computer vision. That means the autonomous driving, driverless driving, and also the power management, and also all the the battery management. So most of the AI techniques are implemented in AI in the autonomous vehicles. The energy management, okay, and so these are some of the areas where artificial intelligence is playing a vital role in EV sector. So one of the things I would greatly encourage faculty members to set up a lab. This is the area built in a small bench models, EV models, have some batteries. Let the students play around it with that, and let the students try to run the prototypes in the bench by keeping certain rollers and driving and consume energy from the battery and take all the data, okay, and try to, with the various scenarios that you can develop, I would strongly recommend and to predict the state of the charge and state of the health of the battery and the remaining useful life. These are some of the important area where students can take a lot of interesting projects. So one of the major area where still there is a research required is environmental changes. When the environmental changes, when the driving behavior changes, when the different geographical location, when the vehicles thinks, I wanted to predict the excellent the battery status and the energy utilization for my best to the vehicle. Okay, that is one of the important area. So how people are now, all the EV vehicles are throwing the data. So how our phones are connected to when you have an Apple phone system, it is always connected with the Apple server. There are millions of people who are used around the world. Still, it is under the control. In a similar way, now we are talking about the software-driven EV vehicles. So it is all will be controlled in a single way. So the manufacturers wanted to have a free update of the softwares, free update of the thermal managements, and all those things. So it is all going to form a wonderful AI-driven EV ecosystems. So such a massive growth is happening where the AI is going to play an important role into that. Yeah. So that is one important thing. Okay. So whatever I just summarized, it is there in this. Okay. Some of the algorithms that people can try. Reinforcement learning is the one of the AI ML technique that is very widely used. Autoencoders and also the PSO kind of an optimization techniques are widely used in the AI environment. Now, this AI ML integrations with the MBD is going to provide you an entire EV system in the virtual environment. So before you get into a vehicle development, you would be able to develop a system and you would be able to implement your AI algorithms and you would be able to test it. So one of the use cases we have developed is, so this is one small use cases that been developed in the final itself. Okay, so the entire model, EV system, battery system, motor systems, all this is the model-based system engineering, where we have also embedded certain AI algorithms. So there is a test environmental profile we have taken, and we have used the AI algorithms to optimize our systems and energy management within this way. So this is one of the small use case that I would like to highlight, how the MBD is used to optimize the power electronics units and the battery and the system to validate the EV into things. And when we drive the road profile or the test environment, this is replicated, or this is highlighted the same kind of things what happens in the reality. So MBD is helping us before you get into any physical prototyping, you would be able to validate it and test it in the mathematical environment itself. That is the highlight. So where I said, AI is very important, you would this MBD environment allows you to embed certain AI algorithms for a control and other optimizations. So you would be able to see that you could see in the first graph, that there is two overlapping things. So one is from the physical testing, and another one is the mathematical MBD testing. So it is more close. So now as you all understand now, these kind of mathematical environments are model-based system engineering ecosystems that allows us to build many virtual models and implement AI and test it. And then it helps us to get into a vehicle development. So it is a very important. All we have to update the knowledge and practice of embedded systems. Also, how we can implement AI into that. Okay, these are the other some of the other use cases when it comes to a transmission control, because we don't have any gear shift and other things. Okay, so we need to develop intelligent systems to change the the gears internally and to bring the autonomous, where also we are it is in a complex control systems where we need an MBD and also AI techniques. And these are some of the use case example that we built inside our office. Yeah, this is some of the test validations. We could able to see the very close correlations when we develop the things. Coming to a conclusion. Okay, so it's a very important topic for faculty members. From the it is time. Sometimes joint collaborated projects is always greatly encouraged. Power electronics team is very important here when it comes to EV, with a good control system knowledge. Mechanical engineers, automobile engineers for a structured design and the system integrations are very important. Software engineers, by closely working with the automobile engineers and power electric drive engineers to finalize some of their algorithms to match the requirements. So always it is encouraged and motivated to the faculty. It's a motivation to the faculty members to update irrespective of the department. We all have to update ourselves for the basic understanding of the electric drives and the lithium ion battery functions and the energy management. And it is very important automobile people also to learn certain control systems and the health monitoring parameters, how AI is using SOC, SOH, SOL related parameter identifications. A basic fundamental of deep learning and machine learning algorithms, how the integrated AI systems are developed, our autonomous ADAS systems are working, and what are the basic major components in the EV based vehicle autonomous. These are the important things, skills faculty members are motivated to update. When it comes to technology, MATLAB, Simulink is the models which enable you to do a lot of MBD work. And there are a lot of other technologies also available. But MATLAB, Simulink has been a long time for in the MBD area. Python programming and understanding is very important. Control algorithms, various control algorithms are greatly encouraged people to get update, and data acquisitions and techniques, and other model-based system simulations like these days car sims. These are the technologies faculty members can update. Also, these technologies can be brought into the lab exercises so that students will develop certain MBDs and AI models to that. Thank you so much. And this is what I just wanted to quickly share in this, our 45 minutes of our the presentations. I know there will be a lot of questions and practical understanding related questions. We are very happy and we are tied up with Crescent University. And you can post your questions. Maybe I will take one or two questions from the team, and then based on the coordinators' time availability, I would like to take it further. Now I hand over the session to the coordinator to, if there is any questions we would like to answer. Thank you so much for listening, and I appreciate everyone's patience in listening and joining in this faculty development program. Thank you. Looking forward to your questions now.
Now the session is open for participants for question.
Sir, good evening, sir. Sir, can you please open that simulation file, sir? Simulation slide.
Excuse me?
Sir, can you please open that simulation slide, sir? MATLAB simulation slide.
MATLAB simulation slide.
Yeah. No, yes, sir. Yeah, this one. Sir, good evening, Professor. So thank you for your presentation. So I have a small query about this slide. So here the text environmental, you are talking about you are going to use the AI algorithm. And here my question is, which type of algorithm you are using, and what way this algorithms is going to improve this model, and what are the parameters you are going to consider in this case?
Okay, and it's a very good question, and there are various various things and various different algorithms are being used actually, and maybe there is a separate session. I think even in this program itself, Dr. Paul Satyan is going to take. Maybe in that session he would be able to help you to share more. When it comes to an time series based certain things, most of the algorithms like LSTM is being used to predict the SOC, SOL, and kind of things. So people are using a lot of regression models. People are using a lot of time series based deep learning models to do that, and day by day they are inventing the things. It is in our hands. Okay, when you have a basic understanding of the supervised, unsupervised learning and reinforcement learning, or a good understanding of the time series based algorithms, you would be able to nail down to what kind of algorithm would fit into that. Maybe to explain those details into that, we have to go component by component. Maybe separate sessions or other things definitely would help. And this is in one open paper. It is in a Toyota things. Some papers are available in the in the open source also. I would greatly encourage people to search and get more details. And there are n number of sample examples for EVs, drive controls are given in the MATLAB Simulink examples itself. Definitely that would help for you to understand more. So due to the time of hacking, and also since I'm in the airport, I may not be able to deep dive into that, but I would greatly encourage faculty members and students to go through the examples given, use cases given in the MATLAB Simulink document. Okay. Yeah.
Okay, sir. Thank you, sir. Thank you very much.
Thank you. Any other questions?
Yeah, sir. Very nice presentation, sir. I'm Shahul Hamid.
Yeah.
Sir, actually, I wanted to know whether what level of the specifications are required to build the model-based,
design for EVs. Yeah, it is a very good question, sir. Very good question, sir. It is it's a very good question. In a vehicle, when the vehicle is what is the basic parameters? Okay, you need to have a basic understanding of the forces that are acting on the vehicle. Okay, how much the rolling resistance, how much the aerodynamic forces, and what is the overall weight of the vehicle, how many passengers, what is the laden and unladen mass of the vehicle. Okay, and when it comes to and how much torque is required. Okay, what is my acceleration and deceleration expected behavior, and what kind of braking. There is so much of in automobile, the basic things that's going to be an input that will drive you to estimate the power required and the torque required. Okay, and that's the way the automobile industries design different vehicles and with the different segments and variants. Okay, so these are the important parameters, and with that parameters, and then they get into the additional things. Okay, and also the cost is going to play an important role as you take in a higher battery and the charging time, and there is a fast charging and the AC or DC charging. Okay, so these are the parameters, maybe in 1,000 parameters will be then a basic input to decide, okay, what is the vehicle structure, and to decide the structural parameters, to decide the control parameters, to decide the energy systems. Okay, so once you started closely working with automobile and looking into that, you would be able to understand the things. I hope I just slightly given the answers. Maybe for a detailed answer, we can discuss.
Thank you, sir. Thank you. Understood.
Thank you. So thank you so much. If there is no question, I know always, I tie up with the department. Dr. PDJ Jayakumar sir is always, touch with us. And if any more questions or anything, feel free to email to us, and we would be able to develop. But this is a growing area as automobile department and power electronics department and AI and computer science departments. It's a time to join together, hands together, to develop certain programs and prototypes and encourage the students to carry out a lot of projects in this area. At the same time, it is a time to update the faculty members, also to update the skills on these areas for a better understanding and growth. And with that, I just would like to thank the coordinators and the university's registrar and vice chancellors for the opportunity to be the part of this program, faculty development program, and also would like to thank AICT for the funding and other things. Thanks to one and all. Thank you so much. Have a wonderful week.
Thank you. Thank Albert Einstein, sir, who in spite of his busy schedule, agreed to enlighten on artificial intelligence. This lecture was highly informative, touching upon the various aspects of this cutting-edge technology. Sir, your lecture has greatly enlightened us and helped us gain better understanding of this subject. I once again thank you, sir, for sharing your time and knowledge to us from the land of rising sun. Thank you, sir. Thank you very much, sir.
Thank you very much. Thank you, one and all. Thanks for your, accepting me, and thanks for your time. Thank you very much. Have a great evening to all.